Welcome to SQL Database Exploring Essential Query Techniques. In today's digital age, data plays a crucial role in every aspect of business operations, whether it's tracking customer information, managing inventory, or analyzing sales trends. Databases serve as the backbones for storing and organizing vast amounts of data. To harness the power of this data, it is essential to establish a connection with the database server, which allows us to interact with the data stored within. In this guide, we will explore the fundamental concepts and techniques related to working with databases. We'll be starting with by gaining an understanding of what a database is and how it is structured. We'll delve into the concepts of tables, which are the basic building blocks of a database, and learn about different data types that define the characteristics of the stored information. To retrieve specific data from a database, we will explore the powerful select statement and how it can be combined with filter criteria to extract relevant information. Additionally, we will discover the concept of joins, which enable us to combine data from multiple tables based on common values. This technique provides us with a comprehensive view of the data that spans across different tables. Subqueries will also be explored as a way to create more complex queries. These nested queries allows us to perform calculations or retrieve data based on the results of another query, offering enhanced flexibility in retrieving precisely the data we need. As we delve deeper, we'll uncover the power of aggregate functions. These functions enable us to perform calculations on subsets of data, such as calculating averages, sums, or maximum values, allowing us to derive meaningful insights from our data. Furthermore, we will explore the concept of case statements, which provide conditional logic with queries, allowing us to manipulate data based on specified conditions. This flexibility is especially useful when we need to transform or categorize our data in a specific way. Additionally, we will discover a range of built-in functions that are available to us, which can be used to perform various operations on data within our queries. These functions provide additional capabilities and allow us to manipulate, format, or analyze the data in different ways. Finally, we will gain insights into the query execution order, understanding how the database processes and executes our queries step by step. This understanding is crucial for optimizing query performance and ensuring efficient data retrieval. By the end of this guide, you will have a solid foundation in working with databases, enabling you to effectively connect to a database server, retrieve, manipulate, and analyze data, and gain valuable insights to support informed decision making. So, let's start embark on this journey of understanding databases and harnessing their immense power. Now we'll see how we can connect to a database server. In order to connect to a database server, you should have the server details. But let's say you do not have any server details at all. In that case, you can go ahead and install SQL Server on your machine and then connect to that SQL Server. To do that, what you need to do first is search Google and search for this keyword, download SQL Server Management Studio. You'll be redirected to this page. Here, you can see that it says download SQL Server, top right corner. You download that, install the server, and then you need to install the SQL Server Management Studio. Now, SQL Server Management Studio gives you the ability to connect to a database server and query that database server. So here you have the link to download SQL Server Management Studio. Click on this, and once downloaded, execute the executable, and after that you will be all set to connect to the database server. For example, over here I have installed Microsoft SQL Server Management Studio and SQL Server. Now you'll see that in order to connect to this server, what I need to do is click on this connect button and then select database engine. This will bring this pop-up, And here you'll notice the server type as I selected earlier from Connect to is database engine. Now this is the server name. This server name, if you're installing SQL Server on your machine, might vary, and when you're installing it, at that point you will be having the option to name this SQL Server, and based on that this will appear over here. So you need to have this handy when you're installing SQL Server on your machine. Then the authentication is there. So here you can see it says Windows authentication. If you click, you can see a couple of other authentication types. For example, SQL Server authentication and then Azure Active Directory authentications. We'll be exploring these two authentications in this tutorial. So let's start with Windows authentication. This means that it will log you in with the credentials that you have used to log into the system. For example, here the username by default says, in my case it says core/kprep, and in your case it could be something else based on your Windows authentication. Now click on the connect button in order to connect to this server. Now if you have a different server, let's say something of a RDS sort on Amazon Web Services, in that case you will have this SQL Server authentication, and then the credentials will be here, the username and password. So this is the dummy data that I've entered over here for an anonymous AWS RDS instance. Now let's go ahead and connect to the local SQL Server. Click on the connect button now, and once it's connected, you'll be able to see all these objects over here: database, security, server objects, replication. Now the first thing that we'll need to explore is databases. Database over here shows the collection of databases that this particular server contains. Now if we have to explain what exactly a database is, we can see that a database is primarily collection of tables. So here we have taken one example called Northwind database, and this one, if you see, has got some tables like categories, customers, employees, orders, products, shippers, suppliers. So as I was saying, a database or a relational database can be termed as a collection of tables. Now each of these tables are connected with each other using some keys. Let's explore that concept now. For example, if I open up customers table, you can see that this table stores all the customer related data. For example, company name, contact name, title, address, city, region, postal code, country, phone, and fax. But you'll also note that it also contains one unique column called customer ID. And here you can see that it says PK, which means that in this table, customer ID is the primary key. Now, a primary key in a table is used to uniquely identify a record in the table. So basically, if we say what exactly a table is, it's a collection of columns and rows, as you might have seen in spreadsheet examples like Excel and all. And here, each row is uniquely identified by a key, which is known as primary key. In this case, it's customer ID. Please note that there will be instances where more than one column can be taken into consideration to be termed as primary key. Those are known as composite keys. So here we have known what exactly a primary key is and what exactly a table comprises of. Now here you see that customer ID is a primary key, but now if I go to the orders table, every customer will place some order. And what we are doing is we are storing that order information in a table called orders. Now, as I was saying, In relational database, the tables are connected with each other via keys. If you notice over here, the orders table also has a primary key called order ID. So order ID is uniquely identifying each order in the orders table. With that, you also see customer ID. Now, customer ID, as I was saying, uniquely identifies a customer in customers table. So here, in orders table, it is treated as a foreign key. The difference between a primary key and a foreign key is a foreign key can be null, but whenever you are defining a column as a primary key, that column will never be null at all. Now, what we are doing over here is we are saying that of all the customers who have placed the orders, their reference will be stored in the orders table, and the column that will be used to connect orders table with customers tables will be customer ID. And that's what foreign key is. A table can have more than one foreign keys, as we can see in this example. For example, orders table is also custom consists of other references to other tables. For example, employee table. So here we have employee ID, and similarly shipping table. So we have the shipped via. Okay. Now we have explored databases, tables. Let's see how we can create database and tables once we have connected to the server. In order to create a new database, you just select the databases, right click, say new database, and then this dialog will appear. Here, you can just go in and write the name of the database that you want to create. You can leave the owner as default and the other settings as is. Click on add, and this will add a database. And click on OK, and this will create the database with this name Skill Bakery. Now, once you have created the database, you can go in and create tables. You'll notice that this already has some predefined system tables over here. So, all the system tables that are there, for example, if I open up this one, system databases, will have master and all. So if there are any system generated tables, they will appear over here. But all the user created ones will come up when you click on table, new table. And here you can see that it presents you with this interface, which says column name, data type, and allow nulls. So let's say we try to create students table over here. For that, the first column that we need is a student ID table. Now, a student ID is going to be primary key, and in our case, it is going to be an integer value. So here, if you see, these are all the data types that SQL Server provides. For example, if we start from the beginning, it says bigint, binary, bit as in true, false, char, date, date time, and some versions of date time like date time offset. Then we have decimal, float, and other specific to industry requirements, geography, geometry, hierarchy ID, image, int. In this case, we will be using int or integer for student ID. Other than that, we have money. So let's say you want to store some financial data. You can make use of money as the data type. Then we have nchar, ntext, numeric, nvarchar, nvarchar max, real, small date time, small int, small money, SQL variant, text time, timestamp, tiny integer, unique identifier. This is basically a GUID value that you can, insert for a given column. Then we have the var binary and var binary max. Whenever you see max to a given column or data type, What it means is if you do not know what is going to be the length of the content for that column, you can just go with the var max option. So in this case, var binary max or var char max. See here, like if you know that the column is going to contain only 50 characters, you can say var char 50. Then if you want to store XML, you can have the XML as the data type. So let's start with integer, student ID. And then, as I was saying, this is going to be our primary key. So what I'll do is I'll say set primary key. This allows me to set this column as a primary key column. Now, as this is an integer, I want this to auto increment. To do that, I'll go to identity specification. So remember that you have to select this particular row and then go to identity specification, and here you'll select yes. You'll see two things auto populating. This is identity increment and identity seed. Identity seed is the initial value using which the increment will take place. For example, in this case, I'm saying identity seed as 1 and increment 1. So it says like starting position or starting value is going to be 1, and then whenever the next ID is generated, 1 will be added to the previous value. So if it's 1, the next one will be 2, and the next one will be 3. So you can tweak this as per your requirement, but initially we will be going with the default sets. Okay, now you have created a column called student ID as a primary key, and next what we'll do is we will store the name of the student. Let's say we say first name, and here what we'll do is we'll say okay, first name. So we know that it's going to be varchar, and let's say 50 characters. Similarly, we can have middle name, and middle name could be null, so we'll leave this as is. And here also we will say varchar 50. Now we'll go with last name, and here also we'll say varchar 50. Let's say we also want to store the date of birth. So we'll say date of birth. And here we'll have the date time as the data type. We can have the email ID of this student, which is again varchar, and this is, we'll say 256. And then we can have address, and this could be varchar max, let's say. Okay. And here we'll have created day. So you can see it as date time. This is to ensure that, when this particular record was created in the database, we can have this column, created date. Now let's click on save. And here you'll notice that it's prompting me to give a name to this table. So I'll say students, as that's what we will be storing over here. So that's how you create a database, you create a table within a database, and you specify various data types based on the kind of content that you would like to store. As I just demonstrated over here, like student ID being integer, created date and date of birth being the date time, and other attributes like first, middle, last name, and email as varchar with different lengths. So to summarize, we can say that RDBMS is a software system that manages relational databases. Key features being it organizes data into tables with rows and columns. It establishes relationships between tables through keys. It provides a structured query language, also known as SQL, for data manipulation. It ensures data integrity and consistency. It supports concurrent access and transaction management. Now, we have also covered the data types in SQL Server. Here, we have categorized them based on their types. For example, numeric types consists of integer, used for whole numbers, decimal, used for precise decimal values with configurable precision and scale, float, which is used for approximate numeric values, and then money stores currency values. Next, we have character string types, which is varchar, meaning variable length character string, up to 8,000 characters. We have nvarchar, variable length Unicode character strings. Then we have char, which are fixed length character strings, and nchar, fixed length Unicode character string. Then we have date and time types. Date stores a date value, and datetime 2 stores both date and time with fractional seconds precision. Time stores a time value, and then date time offset stores a date and time value with time zone offset. We have Boolean type, that's bit, represents a binary value of either 0 or 1. We have binary types where we have var binary, variable length binary data, and binary, fixed length binary data. Other types like XML stores XML data, geography stores geographical data, hierarchy ID stores hierarchical data, unique identifier stores a globally unique identifier, that's GUID, and SQL variant stores values of various data types. Now, let's see how and when we should be making use of the data types, specific data types. Now let's see the usage of data types in SQL Server. Following factors should be considered, like data range. Choose a type that accommodates the range of possible values, storage size, optimize storage requirements based on the expected data volume, data integrity. Ensure that the chosen data type supports the intended data validation rules. Performance. Certain data types may offer better performance for specific operations. Examples: integers should be used for storing employee IDs, quantity, or age. Decimal is suitable for storing monetary values with precise decimal values. Float, handy for approximate calculations or scientific measurements. Money, used for storing currency values. Varchar, suitable for storing variable length text data such as names or addresses. Nvarchar, ideal for storing Unicode text data. Char, used for fixed length character data. Nchar, suitable for storing fixed length Unicode character data. Date, used for birth dates, transaction dates, or event dates. You can also make use of date time, the time value being 0000 in that case. Date time 2 stores both date and time with fractional seconds precision. Time stores a time value. Date time offset stores a date and time value with time zone offset. Bit, handy for storing Boolean values such as true, false, or yes, no. Var binary is useful for storing binary data like images or files. Binary, used for fixed length binary data, and XML or SAML, suitable for storing XML data. Then we have geography, which stores geographical data such as coordinates or shapes. Hierarchy ID, used for storing hierarchical data such as organizational structures. Unique identifier stores a globally unique identifier, that's UID. SQL variant stores values of various data types. So that was a quick recap of what we have studied till now. Now that we have done this, let's proceed further and explore how exactly we will be querying this database and all the information that we have stored in different tables. Okay. SQL Server Management Studio provides some interactive ways of querying the tables that we have inside our database. For example, over here, if I want to list all the customers that are there, I have this option which says select top 1000 rows. So if the table consists of less than 1000 customers, it will display all that information. Otherwise, it will limit the result to top 1000 rows. So you can just go in and say select this. And here you'll notice that it automatically generates the query which yields this result. So it says select top 1000. So remember this top keyword. And if we just remove this top 1000, which is limiting the results set to 1000 records, it's going to fetch all the data that's there in the customers table. Now here we need to understand a couple of things. For example, the first thing that it is doing is it's saying select. So it's a predefined keyword which we are writing, and then these are the column names of that table. So you can see customer ID, company name, contact title, address, city, region, postal code, country, phone, and fax. These were all the columns of customers table, which we can see here. So that's what we are writing, that select all these columns. And from where you are selecting all these columns, you're selecting it from the Northwind database. DBO is the schema and customers is the name of the table. So it's returning you this result. Now this you can further shorten. If you just want to display all the columns, instead of writing each column, you can just go and say select star from database.schema.table name. So if I run this, the output remains the same. Now here, if you have already selected the database, as you can see on top, we have selected this database as Northwind. So what I can do is I can remove this from here, from the select statement, and I can execute this. I'll still get the same result. I can also further go and remove this schema, as that's the default schema if you see over here for all the tables that we have. So DBO being the default schema, we can remove it, and the SQL Server Management Studio will take care of this on its own. So now if I go and run this, you get the same result. Now here, other thing to note is these keywords that are highlighted in different colors. So these are predefined keywords, meaning that you cannot have any column name or anything of this sort predefined already, and you're making use of the same keywords in your table as column names. If you do that, you can still play with it. For example, you can specify that column name within rectangular brackets. Okay. So here we are saying select all from customers. Now if I remove these brackets as well, still this is going to work well. But consider the scenario where you have the table name with spaces. So in order to query that, what you'll have to do is you'll have to put that particular table name, which will have spaces, for example, customers info. If that is how your table name is, then you will have to specify it inside rectangular brackets. Okay. Otherwise, you're good to go like this as well. So this was one way of, querying the tables. The other thing is, like, if you want to edit something, so what you can do is you can click on this edit top 200 rows. So this gives you the ability to go in and edit these top 200 records. This also allows you to insert a new record over here. So you can just go in and type something over here, a new record will be inserted. And if you just modify anything, for example, over here, let's say customers, if you modify the name like this or contact name, you can see the edit icon is appearing over here. And if you just change to a new column or new row, this will highlight as red because this is the value that has been changed. Now if you want this to persist, what you can do is just move to another row, and this information is now updated. You can go back and undo this and move to another one. The same will be updated again. So that's how you can edit records as well using SQL Server Management Studio. Now this also comes in very handy when you need to generate some things. For example, you need to generate the table of the script. Over here you can see it says the script table as, and then you can say create to, and here we have the new query editor window. If I do this, it will open up a new tab And here, generate the script required to create customers table. So you can make use of these context options to achieve various tasks. Similarly, you have other options like select to, insert to, update to, delete to. So if I select to, new query window, you can see that's giving you the select statement. Similarly, if you go in and say script table as insert to, yeah, it will give you the insert statement. So you can just go in and change these values, okay? And then when you will execute this, it will insert a new record in the customers table. Now let's go ahead and try to write our own queries using the select all from customers table. Okay. In order to write our own queries, first thing that we need to do is select the database and then right click, choose new query. This will open up a new tab. You can also do the same thing by clicking over here once the database is selected, like new query. So that will again open up another tab. Let's close this one. And here we have the query editor. And on the other side, we have the Object Explorer where we see the database and tables. Now let's say we need to retrieve the top 5 products based on their unit price. So for that, we'll be making use of the top keyword like this. Select top 5, product name, unit price from products, and then we have this order by unit price descending. What this last statement means is we are ordering the results based on unit price from increasing to decreasing order. So here, if I run this, you'll notice the highest price is coming on top and then the lowest one is at the bottom. And these are the top five products based on unit price. Now let's go ahead and work with some other clauses like in, not in, and like. For example, if we have to retrieve orders from specific customers using the in operator, we can go ahead and write a query like this, where we are selecting the order ID and customer ID from the orders table, where the customer ID is this. So you can see that we have the result over here using the in clause. Similarly, let's say if we have to retrieve orders from customers not in a specific country, then we'll make use of the not in operator, and the query would look like this, where we are selecting the same set of columns, order ID and customer ID from the orders table. But this time we are making use of the not in operator, and we are saying where the customer ID not in USA, UK and Germany. And there we go. So you can see that it's giving me all the results which are starting with the keyword CHAI or chai. Now if I remove this and I put the % symbol before this and run this, it will give me all the keywords which are ending with the word CHAI. And if I put % symbol both the ends, this is going to give me all the content which contains, let's say, the letter C. So here if I run this, you can see that C is part of all such products. So when you're making use of like clause, you have the option to find something which is starting with a given keyword or ending with a given keyword, or that keyword is part of a given string. So that was the like clause. Now we also have group by clause which we can use. For example, let's say we want to retrieve the total number of orders for each customer. So what we can do is we can just say that from the orders table, give us the customer IDs and the count of order IDs. And here we are grouping this basically on customer ID. So for every customer ID, we'll be able to know how many orders were placed. So let's run this and see over here. So a customer with ID ALFKI has placed total 6 orders, and that's possible by making use of the group by clause. Now let's go ahead and try to explore select statements which queries multiple tables. So whenever we have to query data which encompasses multiple tables, we make use of joins. Now in SQL Server we have inner join and then outer join. Outer join is further broken down as left outer join or right outer join, and then we'll be also having subqueries and multiple inner joins. Multiple inner joins basically joins more than one table in a SQL query. We'll also look at equi or self join as well. So let's start first of all with inner join. So let's say we want to retrieve orders along with corresponding customer information. So what we'll do now is we'll be writing a query, and here you can see that we are joining orders table with customers table on customer ID. Now here in orders table, customer ID was a foreign key. So here you can see that when we were saying columns, the customer ID was a foreign key, and the customer ID in customers table was primary key. So here if I explore this, customer ID is the primary key. Now what we are doing, we are joining orders and customers table on this condition where both these columns have same values, and based on that we are trying to get the order ID and name of the customer or contact name of the customer. So let's run this, and there we go. We have the order IDs over here and the contact name. So that was inner join. Now let's take a look at left outer join, where we will be retrieving all customers and their orders, including customers without any orders. So that will be our left outer join. Now here what we are doing is, you'll notice that this time we are joining customers with orders as left outer join, and the criteria remains the same, customers.customer ID and orders.customer ID. This time when we run this, we'll get all the customers with orders as well as customers without any orders. Okay, so this is left outer join. Now coming on to right outer join, where we will be retrieving all orders and their corresponding customer information, including orders without any customers. So here we are making use of right outer join on these two tables, and if we run this, we'll have the order ID and contact name. Now next example that we will be covering will be of subqueries. Let's say we have a query where we want to retrieve orders placed by customers located in the USA. So what we'll do is we'll have this query where we are saying order ID and order date and customer ID from customers where country is equal to USA. So again we are making use of in statement as I mentioned, but you can see that within a query, that is, this is the query, and within this we are using another query. This is known as subquery, query within a query, and the result of this subquery will be passed to the main query, and then the data will be retrieved. Please note that whenever you are writing a subquery, the criteria should be such that if you're using in, it can provide you with a list. Otherwise the value should be within that range, and you cannot have multiple columns. So if you're trying to say let's select customer ID comma contact name from customers, this is not going to run. It will end up as erroneous query. Okay, so let's run this now, and here we have the order ID and order date for such orders where the country is USA. Now let's say we want to retrieve order details along with product and category information. So here we are talking about joining more than two tables. So here, if you see, we have the orders table, we have the order details table. Order details over here was with a space, that's why you're getting a red squiggly icon. I have just renamed it to order details without any spaces. Now, this one is being joined with inner join on this order ID. And then we are joining products table with order details table where we have the product ID. And then we are further joining the categories table with products.category ID on categories.category ID. Now if I run this one, we'll be getting the order ID, the product name, and the category to which this product belongs. So that's how we make use of multiple inner joins. Okay. Now there's also a concept called self-join or equi-join. For example, let's say you want to retrieve employees along with their respective managers. Now here, managers are also employees, but with a higher designation. So the data for employees as well as managers is residing inside a single table called employees. But here, if we have to get this information, we will be inner joining employees table with employees table itself. And here you can see we have given a different alias to the first employees table in the query as E for employees and the other one as M for managers. And what we are doing is we are saying that E.reports2 is equal to M.employee ID. So now if I run this one, we'll be able to see for employee ID 1, name is Nancy and manager's name is Andrew Fuller. So that was inner join. We'll now be moving ahead and exploring some aggregate functions or built-in functions which are provided by SQL Server. For example, first one that we'll be exploring is count. So if I say I need to retrieve the number of orders in the orders table, I can just go in and say select count order ID as total orders from orders. Now here you can see that what we are doing is we are saying count order ID and then we are saying as total orders. So this is like providing an alias to a column. This is what we were doing over here for tables when we were writing equi-join queries. So we are saying employees as E, and that's how we were referencing the column names on top, E.employee ID and M.first name. In the same way, here we are giving an alias to this column. This is a computed value, and for that we are saying that the column should be named as total orders. So if I run this now, I'll get total orders as the column name and the value as 830. So that was the count method. And now the next one that we'll be exploring will be sum method, and sum can be used to calculate, let's say, the total price of all products sold in the orders details table. So here we have sum unit price into quantity as total price from order details, and there we have the total price coming up. Then we have average method, and that is basically used to calculate the average. For example, if we want to calculate the average unit price of products in the products table, we can say select average unit price as average from products, and here we get the average. Then the other one that we will be exploring is max. For example, if we have to retrieve the highest unit price among all products in the products table, we can say select max unit price as highest price from products, and this will give us the highest price over here as 263.50. Similarly, we can say min. So instead of max, we will use min, and min will obviously give us the lowest value, that's 2.50. Now we have string aggregators method, which basically concatenates So let's say we want to concatenate all product names into a single string separated by a comma. So we can use this method to do that. String aggregate product as all products, and there you go. So if I just copy this and put it over here as a comment, you can see all the products that were there in the products table are now presented as a comma separated value. Then we have some other methods like standard deviation, which calculates the standard deviation, let's say, of unit price in the products table. So we will use stdev and pass the unit price column. Now there are some more built-in methods. For example, cast and convert. So let's say we have to retrieve the order date column from the orders table, and we will be casting it to a different data type. So here the query that will write is select order ID, and then we are saying cast order date as date. So here you can see order date was earlier as date time, but now we are saying we are converting order date as date, and the alias name is converted order date. Similarly, here we are saying convert order date using varchar. So here we are saying order date varchar 10, and this is the format that we want to provide 103. Okay, now let's run this. So here we can see order ID, converted order date as date, and then when we are converting it to a varchar value, we are providing the format 103, which means DDMMYYYY. Now let's say we have a scenario where we want to retrieve a list of products from the products table, displaying their names along with the formatted unit prices and a concatenated string of the supplier and category names. So you can see that we have this query now. What we are doing is we are making use of the format function to format the unit price as currency, as you can see over here, dollar amount, and then we are using the concat function to combine company name and category name together, joined by a hyphen or dash. And the name of that column is supply category, as you can see over here. So that's how we can make use of these functions whenever such conditions are required in the query. Next, we will be making use of case statements in SQL. Suppose we want to retrieve a list of products from the products table along with a column indicating whether each product is currently in stock or out of stock. Now, to solve this, we can make use of case statement to accomplish this. So here you can see what we are trying to do is we are saying select product name, units in stock, case when unit in stock is greater than 0, then we are saying in stock, otherwise we are saying out of stock, and then we are ending this case statement from the products table. Now let's go ahead and execute this. So you can see that the case statement is used to check the value of the unit in the stock column for each row. If the value is greater than 0, it will return in stock, and if it's not, it will return out of stock. And we alias this as stock status to make it more descriptive. So that was case statement in SQL. Now let's cover the last bit of this course, that's query processing order. So whenever we are writing a SQL statement, there are following keywords that you might see. For example, we write select all from table name or join or group. So how exactly SQL Server processes it? The first thing that it does is it takes care of the from and joins clause. Okay, so from and joins gets resolved first, then comes where, and after that comes the group by clause. After that we have having, and then we do the select, and on top of it the order by is applied. Finally, if we have a top keyword in the select statement, that is then applied to filter the result set. So this is the order in which SQL Server processes a given query. I hope you have learned something from this course. Thanks for stopping by.